Hello everyone, Quintickle here with another video. Today we're going to talk about functions. Functions, yay! So I'm making this video because in school they teach at least first degree functions. They teach them like a big cloud of weird notations and all that. So I'm here to clear all of that up for you. Whoops, that didn't work out. I'm here to clear it all up for you and make some light. Okay, so the first thing that you are presented with is the notation of a function. At least, again, we're talking about first degree functions over here. F of x is equal to ax plus b. Now, if you're a mathematician, you're already familiar with this notation. What is this? This is an obvious equation, first degree equation actually, and it might be equal to something. So basically, functions are, if you know programming, these are exactly like in programming. They take a parameter, run something, and give you a value. So for example, if we have f of x is equal to 3x plus b, plus, not b, let's say 3x plus 5, and we've got f of 2, this will be equal to 3 multiplied by 2 plus 5, which is equal to 6 plus 5, which in turn is equal to 11. So it's very useful. You can use it for all sorts of things. Actually, I'm going to make an example. Please be aware this is not a first degree function. For example, you could have a function that calculates all the numbers from 1 plus 2 plus 3 plus n. And that function of n would be equal to n multiplied by n plus 1 all over 2. So instead of writing 1 plus 2 plus 3 plus, plus 20, you could just write f 20. Again, this is I'm pretty sure this is all a second degree function, so I wouldn't go around showing people this. I'm more specialized in first degree functions, but still we're going to talk about them. So what do functions do? I already told you, they run some operations and give you an output. Functions can be as long as you want, as long as they don't exceed the first power, because again, we're talking about first degree powers. You could have 2 x plus 3, everything divided by 3, all kinds of stuff. They can be anything at all. So there is a way of drawing the graph. There are actually multiple ways. I know two, but I know for a fact that there are more, and I'm going to present each and every one of them to you. So the first way is actually quite simple, and it's the way I use in class. So we say that f of x is equal to y. We just give it the name. We use x and y because those are the axes in our graph. This is y and this is x. And we can say that if we need to calculate, let's say we're using the function f of x is equal to 2x plus 2. I'm using this because it divides nicely, you'll see. So we're going to say x is equal to 0. That means that y is equal to how much? Well, if we replace 0 in this, we've got 0 plus 2, and that'll be 2. So y is equal to 2. Then we're going to say, well, if y is equal to 0, then how much is x? We're going to say f of x is equal to y. So 2x plus 2 is equal to 0. So x is equal to minus 1. I moved those in the other direction, those of you who are wondering what I did. So x is equal to minus 1. So we take the point here, and this is this point, and this point, because, no, actually this point. Excuse me, this is positive. We take the point over at 2, and the point over at minus 1 on the x-axis and on the y-axis. And we're going to say that this is A of coordinates 0 and 2, and this is B of coordinates minus 1 and 0. And we're going to say that A is equal to the graph of the function intersected with the OX axis. Is it the OX? Yes, it's the OX. No, it's the OY. And B is equal to the graph of the function intersected with OX. And don't forget my brackets, because I know someone's going to point that out. Okay, now that is perfect. So we're going to draw A right here. A, this is A, and this is B. And to draw its graph, that's very simple. We actually just have to draw a line through these points. I mean, I'm doing this on a graphics tablet. It takes me a bit to measure just this way. It's not perfect, but when you're using paper, you could get much better because you have a ruler and all that. I don't have that right here. So this is one way of drawing its graph. What is another way? Well, another way is very similar, because we know, and it's pretty intuitive to think of it like this. We have O, and let's say Y and X. It's pretty easy to think of this like this. We're going to say f of x. Remember, our function is 2x plus 2. So what we're going to do is basically have a random value, like f of 3, and we're going to calculate it. And f of 3, that's 6 plus 2. And which means that f of 3 is 8. Which means that there is a point, I don't know, I'm going to call it f, at the positions 3, 8, that is part of the graph. Then we take another value, a different one this time, let's say 2, and we get 6 and 2. That'll be 2 multiplied by 2, that's 4, plus 2, that is equal to 8. Which means that there is a point, let's call it M. No, even better, let's call it Q, which stands for quintickle. We're going to, wait, how's that 8? My god. Now I look like a moron. That is 6. Which means that there is a point Q at the coordinates 2, 6. That is all well and good. So we just take these points at coordinates 3, 8. I'm going to approximate it somewhere around here. It's not perfect. F. And this is over 2, 6. So again, I'm approximating. I don't have an actual ruler to measure this. And this is Q. And if we draw a line, we see that we got a very similar graph. Again, you can see that this is 2 and this is 1. I mean, minus 1. But I don't have a ruler. But in theory, it's the same graph. And this allows for a bunch of very nice exercises that you can do with this function thing. For example, if we have fx is equal to ax plus 7, and we know that the point G of coordinates 7, 7 is part of this, then we're going to say f of 7 is equal to 7, because we know that, because if this point is part of the graph of the function, maybe I shouldn't have named this G, it's pretty confusing. I'll name this B. No, Q. Okay, so if Q at coordinate 7, 7 is part of the graph of the function, that means that f of 7 is equal to 7. Otherwise, it wouldn't be part of this graph. So that means that A multiplied by 7, because that's x, this is also x, plus 7 is equal to 7. Wow, lots of 7s there. I did this in order to get precise results, that's why I'm doing this. And I chose a horrible function, but whatever. 7a is equal to 7 minus 7, and 7a is equal to 0, which means that a is equal to 0. I chose a horrible function, which means that f of x is equal to 0 multiplied by x plus 7, or f of x is equal to 7. Another thing that I want to talk to you about is basically if you're given this function But you cannot do the x is equal to 0 thing and then y is equal to 0, because you never get y is equal to 0. You always get y is equal to 7. So the graph of this function is simply the two axes. Okay. And a graph that is just a parallel line going to 7 right here. And why is that? Because technically what the graph is if you take this point, and what's its x coordinates? It's minus, I don't know, 4. That means that its result, if we apply the function, it's going to be 7. And no matter what point you take on this graph, it's always going to be 7. So we have a parallel line to the OX that is traversing the point 7 in the graph. Now, another thing that I want to talk to you about is equations with functions. For example, if we have f of 2x is equal to x plus 5, it means that, no, actually no, you can't do that. I mean you can, but it's much more complicated. F of x is equal to 2x minus 5, and you're supposed to calculate how much, if you're supposed to calculate a number knowing that f of 2 plus f of m is equal to, I don't know, 9, taking a random number. So f of 2, how much is it? We replace the x, we get 4 minus 5 plus 2m minus 5, and it's equal to 9. Well, how do we solve that? Well, it's easy. We got minus 1 plus 2m is equal to 14, which means that 2m is equal to 15, which means that m is equal to 15 over 2. And we've solved the issue. Now, there's another thing that kids get wrong really often. For example, when we're given sums of functions, for example, f of x is equal to x plus 2. I'm giving an example again. And you have to calculate f of 0 plus f of 1 plus dot 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 plus f of, I don't know, 10. So how do you do this? Now, a lot of kids really get this wrong because they say, well, it's easy, it's x plus 2, all, and you just do x plus 2 over 0 plus 1 plus 2 plus dot 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 plus 10. And that's your result. Well, this is actually not correct. This is not how you get the result. This is wrong. Wrong. And I'm going to explain in a second why that's wrong. Because basically in here, when you raise the number of the function, this 2 doesn't change. So what you actually have to do is x plus 2 plus, this is actually just 2. 2 plus x plus 2 plus 2, no. I'm wrong. I'm wrong again. F of 0, that'll be 2. Plus f of 1, that'll be 1 plus 2. F of 2 will be 2 plus 2. Dot dot dot, and the last one will be 10 plus 2. So we just take all the 2's, put them separately, and there are 11 terms in this sum, which means that it's 2 multiplied by 11, plus. And now we can do that thing of 1 plus 2 plus 3 plus dot 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 plus 10. And the reason I haven't added 0 because obviously addition with 0 doesn't do anything. So the correct result would be 22 plus 10 multiplied by 11 all over 2. Obviously I know the answer to this is 55, but I'm going to present it anyway. So we have 22 plus 55. I divided this with 2 and we got 5 multiplied by 11, and that's 55, and it's equal to 77. And this is the correct answer. If you would have done it this way, you would have gotten x plus 2, which will be, well, you can't even have a proper x. You can't do that. This is something that many kids get wrong. So another thing that you might be given to do is, I don't know, f of x is equal to x minus 8. And you're told to do f of minus 1000 multiplied by f of minus 999 multiplied by f of minus 998 multiplied by etc, 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 multiplied by f of 2000, I don't know. Now, at first this seems very intimidating to solve. Even I, when I saw it first, I said, well, how do I do this? This is impossible. But if you look closely, I'm going to ask you a question. How much is f of 8? Well, that's easy. According to what we just learned, it's 8 minus 8 and it's equal to 0. Is f of 8 part of this thing? It is. Then it means that this whole thing is equal to 0. And you've solved the issue. Usually when they give you such a big product of so many factors, you normally cannot calculate this. If there wouldn't be an f of 8 right there, the number would be horrendously huge. Impossible to calculate. So when you're working with these very big factors, you should always search for the 0 that just basically cancels out the entire equation. This has been my talk on functions. If you enjoyed this video, be sure to leave a like, and if you really enjoyed it, make sure you're subscribed, maybe even share it with your friends. As always, thanks for watching. Quintickle out.